Welcome everyone, my name is Anne Lord, librarian at the Australian Wine Research Institute, and it's my pleasure to welcome you to today's webinar. It is also my pleasure to introduce our presenters, Joel Lisenby and Gary Allen, and from the Bureau of Meteorology, Canberra. I'm sorry, I just pronounced Joel's name incorrectly. It's Joel Lisenby. Joel will be presenting today's webinar and Gary will participate in the Q&A session following the presentation. Joel has a master's degree in atmospheric sciences and is currently a senior climatologist, climate liaison officer at the Bureau of Meteorology. Joel's current position focuses on the communication of weather and climate data, information and expert advice to local and national stakeholders. Significantly, he produces the monthly National Climate and Water Briefing, which summarises the previous month's weather data and provides a 3-monthly outlook of large-scale climate influences, rainfall, temperature and streamflow. Gary Allen is the Supervisor of Regional Climate Liaison with the Bureau of Meteorology based in Canberra as well, and prior to joining the Bureau, Gary led major projects for the New South Wales Government on climate applications and adaptation to the impacts of climate change, including in the wine and other primary industries. He's also worked for the Murray-Darling Basin Commission and has been involved with natural resource management and regional communities for the last 3 decades. Before I hand over to Joel, I have a couple of quick points as to what to expect for those who are new to AWRI webinars. The format for today is a short presentation followed by a Q&A. The webinar is being recorded and will be available to view via the AWRI website. It is important to remember that webinars are interactive and there are a number of ways to get involved. To ask a question, please type into the question section of your control panel in the right-hand corner of your screen. For those with access to a microphone, there is also the option of speaking directly with our presenter by clicking the Raise Hand button. This is located in the top left section of your control panel. Please feel free to send through questions at any time as well as during the Q&A session, and I will get as many questions through to Joel and Gary as possible. Firstly, if you'd like to get involved through Twitter, please use the Twitter handle @the_AWRI. Okay, that's enough from me now, and I'm going to hand over to Joel to tell us more on today's topic.
Hi, thanks, Anne. Can you confirm that you're receiving
yes,
the
yes.
presentation?
Yes.
Good. Thanks for the introduction. It's great to be here. It's good to be able to present with Gary, who is also quite knowledgeable, especially about the wine industry and agriculture and how the weather impacts on the ground. We're going to go through, this is basically the outline of the presentation. First, we're going to start looking at recent conditions. We're going to look at the big picture climate drivers, and then we're going to end up with the most recent outlooks. I like keeping things as casual as we can. If anybody has questions, go ahead and type them in, and I don't mind being interrupted with questions. And Gary, if you have anything to add as I go, just speak up. I think we'll be fine. We're going to start by looking back at what has happened. These are our October temperature deciles with maximum temperature deciles on the left and minimum temperature deciles on the right. October was quite cool, actually, when we look across the country. Overall, we were nearly 0.3 degrees Celsius below normal. There was no state or territory that ended within the top or bottom 10% of recent years or top or bottom 10 of recent years or historical years. Minimum temperatures were about 0.7 degrees below normal, Northern Territory ranked the 9th coolest October on record. For many people, it seemed almost another extension of winter. We had a nice cool winter. September was also quite cool as we started spring, and in October the spring temperatures weren't quite what we would expect long term. While we're on the topic of, well, before I move on from temperatures, this just came in. In fact, I just made this slide about a minute ago before we started. This data just got in about an hour ago. This is how November ended up. Maximum temperatures were above average in the western half of the country and along the east coast and in the north, but for maximum temperatures, most of the country ended near average for November. Minimum temperatures again on the right, similar pattern with some cool anomalies or some below normal, below average temperatures around South Australia. I'm not going to show November rainfall. I just didn't get time within the last 20 minutes or so to grab that data, but looking at overall big picture, November ended up below average rainfall, and I'll talk about rainfall again in a little bit. On the topic of temperatures, we've had some very low overnight temperatures, especially in the south and in the west over the early spring period. This is a count of nights that recorded frost at Merredin, Western Australia in over September and October, with the 2016 period marked on the yellow line. This is the first time since 1978 that we had more than 6 nights at that location recording frost. And this was a similar pattern to what we saw across the southwest during the spring months. With that, I've got a few stats in these dot points here. There was quite a big impact on the grain industry from these frosts, but even with the frost impact, it's likely still to be an above average grain harvest. Anything else to add about the grain or the frosts, Gary?
Only that we endeavoured to ascertain whether any wine growing regions had been impacted in WA specifically, and we couldn't find any evidence of that, but when we get to the Q&A, maybe we can ascertain from people on the ground whether there were any frosts.
Now talking about rainfall, this is the map on the right is the October rainfall deciles, and overall it was a pretty average October. I think nationally we ended about 13% below the long-term average, which is not that notable when compared to previous months that were very wet or very dry. The map on the right is showing rainfall deciles for August, September, and October combined. Knowing that October was pretty average, these very much above average and in some places even highest on record locations for rainfall. Most of that is standout rain that we had in August and September. You probably will remember September. September rain was pretty crazy. It was the second wettest September on record nationally. It was the wettest since 2010, and we didn't break the new record only by about 1.5 millimeters when averaged across the country. It was the highest rainfall on record for any September for New South Wales and the Northern Territory. Second wettest September on record for Victoria, where Victoria doubled their monthly mean rainfall for the month, which was pretty amazing. Highest on record for Queensland. There were some major storms that came through in September. There were 5 frontal systems in 1 month, which is a lot. I don't think we have a long-term record of how many in 1 month we usually see, so I can't say if it's a record or how it ranks, but certainly we had 5 frontal systems within 1 month, which means you probably on the weekend were saying we've got to go mow the lawn, and then it's raining and you say we'll do it next weekend, and then it was raining again, and then you say the next weekend. So that happened. And you also remember, especially those of you in South Australia, the big storm on the 29th and 30th of September that caused a big blackout. So not only was there a lot of rain, but these were very powerful storms that came through. So when we look at the 3-month analysis, a lot of that rainfall is dominated by the rainfall we received in September. As I mentioned a little bit ago, I haven't made a map, or I didn't pull up a map of November. November ended up just a little bit below average rainfall nationally also. We're looking at the soil moisture analysis from October. Now, keep in mind that October was pretty average in terms of rainfall, so most of these are very much above average soil moistures are remnants from the very wet winter that we saw through most of the southeast, and then the very wet September. And looking at just the lower layer soil moisture map alone, which is the map on the left, you don't really get the sense that things are drying out. So I'm showing the map on the right, which is the change in soil moisture from September to October. And with exception to some places in maybe Western Victoria, Mildura region, and maybe the far southeast of South Australia, most of the southern half of the country saw less soil moisture in October than we saw in September, which is what you would expect, but you need a map like this to really tell the story of how things are changing, because the map on the left doesn't really tell that story.
Just to clarify, this lower layer soil moisture profile is the soil at depth from 20 centimetres below the surface to about 1 metre. So it is the deep soil profile where most perennial plants have their root systems.
Thank you. This is the observed stream flow in October. We'll get November's data in about a week for our observed stream flow. It's not a big surprise from the heavy rains and the high rainfall totals that we saw through winter and September, that in October most streams and stream height gauges were showing above average flow or high flow compared to this time of year for October in the southeast. There's just a few stats. I'll take those as red, those just showing how many locations ranked high, near, median, and low. Now we're looking at the storage levels, or the reservoir the total water stored in different parts of the country. Different catchments are shown, and the little bucket diagrams are showing the average of all of the reservoirs in that catchment. So it doesn't really give you any fine scale detail, but big picture you can see what's the state of our water storages now as compared to the previous year. A few good stories that come out of this, looking at the South Australian Gulf region, which is currently at 95.2%, and a big step up from where we were at this time last year. A few other big step-ups were in the Murray-Darling Basin, especially the northern half of the basin, and the Tasmanian catchments are also up a little as compared to this time last year. The southeast coast hasn't changed that much from this time last year, but you can see the little tail coming off the bucket diagram is showing the time series, or how things have changed. So there was a small dip, and it has recovered back to the same place as last year. Do you have any other insight to add to this one, Gary?
I would only draw attention to the situation in WA, Southwest Coast and Indian Ocean, not following suit with much of the rest of the country, reflecting the rainfall situation that we've seen over the last 6 months or so.
It's a good point. Most of the rain that we saw over the last 6 months has been south and eastern part of the country.
Yeah, I should also, just for clarification, Joel's referring to these catchment areas. These are the major drainage divisions for Australia, and what the storages are showing there are those drainage divisions where we have significant storage volumes, and they're aggregated up to give a total figure for each drainage division. We can look at individual storages, but for the purposes of this kind of a briefing, we don't go to that level of detail.
I guess on the topic of rainfall and previous storms, this is a quick analysis of what happened on the November 11th storm across South Australia. First, I'm showing the radar image from, this is about 6 p.m. on the 11th. The dark areas are places where it's labeled as heavy precipitation. It's most likely hail that's coming from those very dark storm cells. The weather map in the middle is showing the synoptic setup. What's the big picture setup for the storm? You had this trough extending up from the Great Australian Bight, wrapping sort of around South Australia and then back up into Western Australia, with a low pressure center right over the Adelaide region. And with that low pressure there, you had this low pressure providing some lift into the atmosphere. You had some moisture in the lower layers of the atmosphere already that just gave you the right mix of conditions to provide to create some very strong storm cells, these convective systems that create good strong winds and damaging hail. It was a very big storm, and certainly worth noting. We're noting the third dot point, $100+ million damage to grape and dried fruit industry. This is some information that we've gotten from just media reports. I'm sure that those of you who were in the region at the time would remember and have more to say about really what happened and what it was like to have these storms come through. Looking at other severe weather, we're coming into the bushfire season. Well, we're in the bushfire season. There have already been 4 major bushfires across Australia this season. 2 have been on the east coast, which over with the winter months when we saw the really high rainfall totals, the coastal regions were in a bit of a rain shadow effect, as most of that rain was coming from the west toward the east. And so there were still some very dry regions along the New South Wales coast that have already had some major fires for the season. The one up in Kimberley was more of a sort of the end of September, early October. It was a fairly large fire up there, but they're just coming to the end of the dry season, and the peak of their fire season is just passing. And then the one in southern Western Australia. The map on the bottom right is showing an update that the Bushfire and Natural Hazard CRC issued only yesterday. So this is a bit hot off the presses, and it's showing the regions of the southern part of Australia that can expect above normal bushfire risk for the coming season. Now, there's a big area over Victoria, New South Wales, and the small parts of South Australia that is colored red and showing an above normal risk. Now, this is also the regions that are showing that above normal rainfall and above normal soil moisture currently. But the risk is that with that increased vegetation growth, if we get a hot, dry summer, that's going to dry out, and we'll see this increased bushfire risk through the rest of the summer. So that's wrapping up our recent conditions. Now, we can now look ahead at the large-scale climate drivers. When I talk about a climate driver, I'm talking about the big picture influences that impact our day-to-day weather. We usually look to the ocean because the ocean changes much more slowly than the atmosphere. And so if we know the state of the ocean, it can give us some predictability as to our weather that we can expect while the ocean is in a certain state. So this rather busy map is of global ocean sea surface temperature anomalies for the week. It's a week average state ending the 27th of November. And I have 3 boxes shown on this map that are areas of interest from a climatological point of view. The box over the Pacific Ocean is a box that we climatologists refer to as the Nino 3.4 box. It's an area right in the center of the Pacific that when we average the sea surface temperature across that box, it gives us some index of the El Nino or La Nina fluctuations. When the ocean temperatures within that box are warmer than average, significantly warmer than average, we're talking about 0.7 to 0.8 degrees above the long-term average, we're usually in an El Nino state, which is what we saw last summer. When it gets cooler than average, again, we're talking about significantly cooler, so 0.7 to 0.8 degrees below the long-term average, we're usually in a La Nina state. Currently, within that box, most of the oceans are near average, with some areas just a little bit below average. And when we look at the bigger picture around the Pacific, there's this area of warm water to the south and to the west of that box. And there used to be warm water to the north, but over the last 2 weeks, that's weakened off. Spatially speaking, that is a La Nina pattern, cool water in the central, right along the equator with warm water surrounding it. And I'm going to show more about this in the next few slides, but so spatially we're showing La Nina, but the strength of those anomalies are not enough for us to be within a La Nina state. So we're still officially neutral, but the ocean tends to be, it looks like it's leaning toward a La Nina. In the Indian Ocean, we have a similar pattern, something we call the Indian Ocean Dipole. And to measure the dipole, we take the average sea surface temperature from the box in the west and subtract it from the average sea surface temperature in the box to the east. And when you get more warm water in the east, you're in a negative Indian Ocean dipole pattern, and that usually means a wet winter and spring for Australia. And when you get the opposite, when you get cool water in the east and warm water in the west, that's a positive pattern, and we usually see drier conditions, especially during winter and spring. So this is the current state of the oceans. We have this weak to possibly leaning La Nina, but it's officially still neutral in the Pacific. And in the Indian Ocean, that is also officially neutral, but what I'm not showing here is that over the last 6 months we've had a fairly strong negative Indian Ocean dipole. We also still have some very warm waters toward the northwest of Australia, a pocket of warm water toward the southeast, just off the southeast over the Tasman Sea. And we used to have a pocket of cool water south of Western Australia, which over the last week has backed off. So with all of that, try to take a mental picture of that and remember that we're going to talk about this in a little bit more detail in the next few slides. So this is looking at the El Nino Southern Oscillation, which combined with, we make that into an acronym, we call it ENSO, and looking at the Nino 3.4 weekly values in that top right. And that shows that at this time last year we were in a fairly strong El Nino that contributed toward very hot and dry summer last year. By about April we came out of that, April to May period, we came out of that El Nino space, and that's about when our weather patterns switched from dry to wet. And then you can see toward the September-October 2016 period, I don't have the years labeled on that, which is a mistake, but this graph begins on July 2015 and goes through November 2016. So you can see that we're nearing that La Nina. That blue bar at the bottom represents the La Nina state. We're near there, but we're really not there. The three graphs across the bottom are the forecasts for that Nino 3.4 box from 8 different climate models around the globe. Different agencies have their different models. Every model is a little bit different. So you want to look at the very bottom bar, which is the mean of all of the different models, and that would give you a good indication of what we expect to happen over the next 6 months. For December, which we've just begun now, we're expecting the ocean pattern to stay in this neutral but leaning toward La Nina state. By February, things have backed off quite a lot, and by April, we're well and truly neutral, and the models, some models are positive and negative, but all within that neutral space. It's very unlikely we're going to cross that line into a La Nina this year, but we'll still, it's important to know that the climate pattern is leaning us toward a La Nina-like influence, which La Nina for the southern half of Australia usually, but not always, but usually means a cooler, wetter summer. So keep that in mind. But also keep in mind that this is just December, and beyond this, the models are suggesting we're going to be well and truly in a neutral space. This is the same thing, but now for the Indian Ocean Dipole Index. And again, the timeline along the bottom of the top graph is July 2015 through to November 2016. In September and October of last year, while the El Nino was building, we also had a positive Indian Ocean dipole. This coincided with the dry conditions that we saw from about October through to, well, beginning in October of last year. And then in about May of this year, we dropped into a negative Indian Ocean dipole space. And through our winter and early spring months, a negative Indian Ocean dipole was the strongest climate driver influencing our day-to-day weather. A negative Indian Ocean dipole usually pushes us toward a wet winter and spring. And the IOD usually backs off to neutral by about the end of November, and that has to do with the dynamics of the monsoon trough moving across the Indian Ocean, and it breaks up that ocean pattern. So we've been in this we've been in this negative Indian Ocean dipole space since about May, and it ended toward the end of October, and in November we were in this neutral area. But this is why we've been so wet recently. Looking at the forecast along the bottom, December, in fact, all models say we're going to stay neutral for December, February, and April, all neutral, which is no big surprise. The Indian Ocean dipole, because of the monsoon dynamics across the Indian Ocean dipole can't really set up until about May or June anyway. So it's not really a thing this time of year. So while we're talking about the Indian Ocean dipole, the one that we just came out of, this negative event that influenced our weather during winter and spring, it ranks among the top 4 Indian Ocean dipole events that we've seen historically. Now our records reliably only go back to about 1960 for Indian Ocean temperatures, but if you look at the rainfall patterns from these top 4 strongest negative Indian Ocean dipole patterns, you can see that generally the southern part of Australia sees more rainfall. It's not labeled here, but these maps are winter and spring rainfall for these respective years. And you can see how 2016 compares with previous years. It was wet. Southwestern Australia maybe missed out this year, where it might have picked up rain in previous negative IOD years. But that's probably just for interest. All right, before I talk about this, I want to say, so this one's about the southern annular mode, but remember that the Indian Ocean dipole is now neutral. By about the last week of October, maybe first week of November, it was well and truly into this neutral space, neither positive nor negative. The Pacific Ocean, although it's been leaning La Nina-like for a few months, it's trending back toward very neutral, and it still is neutral. So the 2 big patterns that drive our climate, the Pacific Ocean and the Indian Ocean, they're both neutral. And so as we're looking at something to give us some predictability for the summer, there's not much big picture stuff to go on. So as a climatologist, what do? Is I look at what's the next strongest signal that might be influencing our weather. And in this case, for the next, at least for the next few weeks, the strongest signal is this southern annular mode. The southern annular mode is the variation in the westerlies that circulate the globe along around the Southern Ocean, so north of Antarctica, south of Australia. When these westerlies shift north during winter, we tend to get more winter rainfall. However, when they shift north during summer, we tend to get less summer rainfall in a negative, and that represents a negative phase. A positive southern annular mode represents or indicates that those westerlies have shifted south, and it also has different impacts on our rain depending on the time of year. I'm showing the time series of the southern annular mode index going back to August of this year, and you can see that in November the southern annular mode dropped to a negative value, and it stayed there persistently for most of the month. And usually, in November is a bit of a transition period from winter to spring, but generally in November we see a drying pattern from a negative negative southern annular mode. And if this negative pattern continues into December, we'll continue to see that drying pattern into summer. That's probably all I have to say about that. If you have questions about that, we can discuss these later. One other thing to add about the southern annular mode actually is that it operates on a shorter time scale than the ocean patterns we look at. It changes on about a fortnight time scale. So if we're in a negative SAM now, in about 2 weeks from now, we don't really know where we'll be. But at least for the next few weeks, 2, maybe 3 weeks, we know we're in this negative SAM space. So with that in mind, let's look at what the climate outlooks are giving us. Now these are outlooks. They're probabilistic forecasts based or produced from a physics-based computer model. So this model doesn't really care if we're in a positive or negative IOD or what the ENSO pattern is looking like. It takes in the current state of the ocean, the current state of the soil moisture and vegetation and temperature and ice around the Antarctic, and it takes in all of these and it calculates what the most likely outcome for the next 3 months is going to look like. And so here we're looking at the probability of exceeding the median maximum temperature on the left and the probability of exceeding the median minimum temperature on the right for the next 3 months, December through February. And it's telling us that both for maximum and minimum temperatures, we've got the same pattern across the country, that it's more likely we're more likely to see above median temperatures for the next 3 months across the eastern part of the country and also in the tropical north. Southwestern Western Australia is likely to see below the median maximum and minimum temperatures for the next 3 months. Now, also you should keep in mind that this is giving us an average, or it's likely that the average for those 3 months is going to be above or below the median. You'll still see some variability throughout the season. You'll still see some cool days, even though overall you'll end up warm, or vice versa. Yeah, you have something to say?
Sorry, I just mentioned the skill maps that are there.
Yeah, do you want to talk about the skill maps?
No, you go.
Okay. The little green maps at the bottom represent the skill of the model, or how well historically the model has performed for this time of year. The darker the green color, the better. The white areas are places that the model got the sign of the outcome right less than 50% of the time. So those areas that are green, the model has historically done well. While we're talking about future temperatures, this is the likelihood of a heat wave happening just for the month of December. These are made using the same model that produced the previous outlook. Now there's 3 different categories of heat wave that I'm showing here. A low intensity heat wave is the yellow one on the left. A low intensity heat wave is one that from a meteorological perspective meets the criteria of a heat wave, though the extremity of the heat and the duration of the heat wave aren't really enough to cause a lot of problems. We might all complain about how hot it is, but the problems that are associated with heat wave don't usually kick in. A severe heat wave in the middle, this is a heat wave that is detrimental to people who are already vulnerable to heat waves. So maybe the elderly or the people who are already sick. And extreme heat stress, it increases the number of both mortality and morbidity rates experienced for any location. And an extreme heat wave, the red ones on the far right, these are heat waves that would influence or could potentially damage infrastructure and could cause health problems for people who would otherwise be considered healthy. So these are the heat waves that you really want to be aware of. And so this map is showing the likelihood that throughout December we will see a heat wave of these different intensities occur. And if you want to know more about these heat wave products, just go to the Bureau's homepage, scroll to the bottom, look for the picture of guys working on a roof, and click on that, and it will take you to the Bureau's heat wave service. It provides an analysis of the heat wave pattern for the last few days, and it also it provides a forecast for the next 7 days of how likely a heat wave is to occur for different parts of the country. Now the rainfall outlook. This is similar to the temperature outlook I showed 2 slides ago. The map on the left is showing the odds of exceeding our median rainfall for the 3-month period, December through February. The map on the right is showing the same thing, but just for the month of December, and how likely it is that we'll exceed our median maximum. The orange and brown amber colors are showing that we're likely to see below the median rainfall for the month of December. December is likely to be dry, but when we look at the big picture, 3 months, looking at a little farther out, mostly just the eastern coastal areas, the Great Dividing Range across the New South Wales, southeast Queensland are the areas that are more likely to see below median rainfall, and northern WA, Pilbara region are likely to see above median rainfall. The areas in white, the odds, you really are looking at equal odds one way or the other. I'm next going to show the chance of exceeding median maximum temperatures for December. Compare that to the rainfall map. It's likely that December is going to be hot and dry from the current outlook. This is now showing the next month, January. The odds back off across most of the country for January, except mostly along the eastern half of the country, where it's still likely to see a dry January. This is a Streamflow forecast for November through January. And the stream flow is still mostly influenced by the wet conditions that we saw through winter and September. And so looking at the next 3 months, well, now it's really the next 2 months because November's already passed. Most stream gauges in the southern part of the country are likely to be above average. The next stream flow forecast is issued, I'm going to forget the exact date, but it's usually sometime toward the end of the first week of the month. So if you're interested in the stream flow forecast, let me know. I can point you to the link and I'll let you know when these are updated. Just a few stats around the number of locations expecting to see high, near, median, and low flows for this 3-month period. 211 out of the 300 locations are expected to see high flows. Near median flows at 62 locations, and low flows are only likely at 27 locations. And keep in mind that this is flows as compared to this time of year. That's probably all I have to say about that. Just to finish up, this is the summary. We've come into neutral El Nino, or neutral ENSO, and neutral IOD, so looking around at what climate driver is the next loudest. It's likely to be a negative southern annular mode. The December outlook is showing a strong chance of warm and dry conditions, especially in the east. Summer temperature is likely to be high, especially in the east. Rainfall, dry in the east, and a few stream flow stats there. I'll finish with that. Happy to take questions for either me or Gary.
Thank you, Joel and Gary. Just to reiterate, to ask a question, please type into the question section of your control panel in the bottom right corner of your screen, or those who've got access to a microphone, there's also the option of speaking directly with our presenters by clicking the raise hand button. This is located at the top left side of your control panel. Right, we've got a question here. I'll just send it to you, Joel. Can you see it?
Yes. So expand it. Can I expand it?
Yeah. That's okay. If you can read it.
I can read it. I don't think I can. You probably can read it here. So thanks to Warren for this first question. He asks, given we have a particularly warm Southern Ocean anomaly, do you expect this to mean a warmer and or wetter short-term forecast? Now the warm anomaly in the Southern Ocean is currently mostly off to the Tasman Sea. I'm going to see if I can pull up my map of the ocean temperature again. Remember which slide it's on. That's not it. Almost there. Okay. I moved that. So most of the really warm water near Australia in the south is off the Tasman Sea. The other area that you'd want to look at is the southern Indian Ocean, where you also have some warm anomalies. Now the question is, would those probably would either of those, either the Tasman Sea or the southern Indian Ocean, give us warmer and wetter short-term forecast? It's a little bit hard to answer, and I think my official answer is going to be probably not, but maybe. So I'm going to keep that maybe just in case. I'm going to explain a little bit about that. The warm waters off the in the Tasman Sea would really only influence our rainfall if you get an east coast low there that would be driving the airflow off the Tasman toward the country. And The East Coast lows, while they can and have happened at any time of year, are more likely to happen in May, June, July, and August. We're getting to the time of the year that most of the lows that are transecting the southern hemisphere are pretty far to the south of us. Now, the warm waters in the southern Indian Ocean, those potentially could be adding more heat and moisture energy to weather patterns coming across. But there's two things that you need to keep in mind about that. One is that we're coming into summer, and it's less likely that if we did get a cold front coming across that it's going to extend far enough up into the continent, across Australia, to really give us that rainfall. And the other thing is that air moving across the Southern Ocean moves really fast as compared to air across the tropics. And where that air is moving really fast, it influences the ocean temperatures just as much or even more than the ocean temperatures influence the air. There is a coupling over any ocean where there's an atmospheric boundary layer that's interacting with the ocean there. But because that air is moving so quickly across that, you really need you need a big area of really warm water for that to have an impact. Now, that area in the southern Indian Ocean, it is pretty big. Is it big enough and warm enough to provide that sort of boost? Maybe. Just looking at a map, it's really hard to tell. But even if it did, most of the lows coming across the Southern Ocean are going to stay pretty far to the south of us.
Yeah, and I just add that what Joel described in relation to the current phase of the southern annular mode means that its influence will be a drying influence, and if you couple that with the other major drivers over the next month or so, if you're interested in the shorter term scenario, it's I think quite unlikely that we're going to see anything significant in the southern half of the country for most of December. Joel did have a look at the weather outlooks before we started, and I don't think they indicated that there was any likelihood of anything in the next 7 days or thereabouts.
No, not, but maybe for Tasmania.
Yeah.
There is a low moving across the bight with a trough extending up toward the country. It might bring some cloud across the South Australia area, but it's more likely that any rain from it will come to Tasmania. Good question, though. Thanks, Warren.
Okay, we have also another question here from Rex Hayes about frost. I'm just sending that through.
Okay, I've just received that. Thank you, Rex. The question is, I have a vineyard in Narrogin. Am I saying that?
I would guess that's right. Yeah.
Narrogin, Western Australia, which in the last 2 years have been badly affected by frost. This year we had frost between the 20th and the 25th of October. Is there any instrument or app which will notify and alarm vineyard owners?
Rex, I'm aware of work that's being done by Peter Heyman, who works in Sardi in South Australia, and you may be familiar with Peter, and he's been focusing on frost impacts not just in South Australia but Southern Australia. As far as warning systems that would alert growers to the potential for frosts, the Bureau has some capability in that regard, but I'm not aware of specific apps that are available currently. I'm aware of research that's going on in that area. My only suggestion re frosts at, I think it's fairly clear that we're now beyond the frost risk part of the year, but certainly it's something which would be extremely important for you in the early part of spring and indeed through from September into November. So we probably take that as a question on notice and look at providing some insights into what is available once we've been able to consult with the relevant experts. But certainly if you follow the Bureau's forecast on the METI site, we have a menu there under forecast which shows storms, snow, fog and frost, and you can select from the menu there if you're specifically interested in frost, and you can then you can look at that for your location, so you can type in your location there, and whilst you're not likely to be able to verify it from this point on, I would suggest that you should get a fairly good indicator of the general potential for frost from that forecast area in METI.
Now, am I still sharing the screen, Anne?
Yes.
So did you see where I just navigated to on the Bureau's website to find that frost forecast?
I didn't pick up the link. Would you
walk
like
through that again?
Yeah, just quickly walk through it.
I'll walk through it again. So just to back up what Gary just said, we don't really have any alerts or apps, but if it's something that you're watching for at a sensitive time of the year, the best thing I can think of is to use the METI tool. So starting from the Bureau's homepage, there's a link right in the middle called METI. That takes you to this tool.
Do you want to type that Narragain in there and see if it'll, if it's listed? It should. N-A-R-R-O-G-I-N. Yep, Narragain, WA. Okay.
That would take you.
Okay.
Zooms in pretty close. This is on a. This is a modeled. Well, there's a forecast product that's displayed on a
graphical
5-kilometer graphical interface. So that's
5-kilometer grid. Yeah.
So each of these, one space would be a 5-kilometer grid. Anyway, there's an option on the left that says storm, snow, fog, frost. Open that, and these are the different options you have. You can select frost. Obviously, this time of year, there's not a frost risk, but if there's frost in the forecast, this would give that to you, and you can look out for the next 7 days. So that's probably the best I have to give you right now, Rex. Sorry that there's not anything better. We'll come back to this.
Thank you, Rex, for that. We don't have any other questions at the moment. If you have a question, can you please send it through quite quickly? Otherwise, we'll have to end the session. Okay, it doesn't look like there's any more questions coming through, so we shall end the session now, and I'd like to thank both Joel and Gary for giving today's presentation, and also to thank everyone who attended and took part in today's session. For attendees, you will receive a follow-up email with a link to this recording and a link to the survey. The next AWRI webinar is on the 8th of December when Kathy Howard will present whole bunch fermentation. If you'd like to register for this webinar, please visit the AWRI website, and that's all we have for today. Thank you again for attending, and I look forward to seeing you again at the next AWRI webinar.